Hello and welcome to this version of orbital dynamics calculation spreadsheet demonstration. We're going to talk today about some of the options that we can use for the single satellite. Now most of these apply for multiple and constellation as well, so we're just going to focus on the single today. We're going to again look at the ISS, and our delta time is less than 2 days old, so we don't necessarily need to update the data on the TLEs because for today's purposes we're fine for accuracy. So let's go to run, select run, and select single. Now it's going to cycle roughly every 2 seconds, which is what we want. Right now if we go back to the satellite and we're going to look, the ISS is currently over South America, Brazil. Alright, cool. So for that's our purposes, good. I've selected Rio de Janeiro as the city we want to look at. So let's go to it. There we go, Rio de Janeiro. We're going to zoom in. Cool. So in a few minutes the satellite's going to come overhead. We'll play with some of these other options in the meantime. Let's go here. So say we want to see the satellite at a precarious angle. Currently it's defaulted to the direction of travel as its yaw direction, but maybe we want to change it at 0 degrees, which means now the ISS is pointed directly towards the North Pole. And that's fine if you want to play with it. Maybe we want to see pitch at 90 degrees and roll at 45 degrees. It's going to be at a rather precarious angle. There we go. The ISS is completely on its side and angled in a weird direction. We don't necessarily need to see that. So let's go back to the defaults and we'll try something else. So say we want to change the field of regard of that cone, the size of it. Go over here to field of regard off nadir. It's currently at 45 degrees off nadir, which means it's a 90-degree cone. We'll pull it down. Maybe we want to make it at 20 degrees, and we go back, and there we go, 20 degrees off nadir. So you can play around with some of these little options. Just, pretty unique, pretty cool functions. So let's go here. We're going to go back to 45 degrees. There you go. And now, because the way I set it up, we've got a field of view cone pointed to Rio de Janeiro. Maybe we don't want to see the field of regard. I'm going to turn that off. And right click there, go to revert, and there you go. Now, it is a tracking field of view, which means it will stay locked on that satellite to the city as long as it's in view of the city roughly. And we can change that around. I can change any city here that I want and do the same thing. It just happened that Rio de Janeiro was the city I chose, so we'll go with that one. Some of the other options, maybe you want to see an extrusion. Maybe you want to see that straight down line straight at nadir. There you go. It's an extrusion. Pops right down and turn it off. Maybe we don't want to see the orbit. Maybe we want to turn the orbit off and it'll refresh. Right click, revert, and there you go. Now you can see the satellite moving along. For any of these options, field regard cone, it's still there. Orbit path, it's still there. Sensor slew is still there. It just depends what you want to see. So we're going to go back to orbit visible and field of regard visible. And these are just some of the default settings. And that concludes today's demonstration on the orbital dynamics calculation spreadsheets. Close this up. Thank you. Please tune back for further editions.